Okay, so starting at section 5, topic 2, where instead of graphing the functions, I'm going to give you a graph, and you're going to be responsible for writing the equations. So just going the opposite direction. Okay, so our warm-up, if you haven't tried this already, pause the video and do it on your own. Quick review from section 5, topic 1. To identify the axis of symmetry, you want to use x is equal to negative b over 2a. Remembering that this is a, b, and c. So that would be a positive 4 over 2 times a, which is 1. 4 over 2 is equal to 2. So axis of symmetry is at x equals positive 2. And we show that with a dashed line. Because it's not actually there, it's just an invisible line. Then our vertex is going to be, we get that by plugging 2 back into this function. So we'll have 2 squared minus 4 times 2 plus 3. 2 squared is 4. Negative 4 times 2 is a negative 8 plus 3. 4 minus 8 is a negative 4. Negative 4 plus 3 is a negative 1. So our vertex is going to be at 2, negative 1. 2, negative 1. This graph is definitely going to open up because a is positive. So we're going to have x-intercepts and we'll have a y-intercept. I can look at C and that tells me my y-intercept without doing any work. So y-intercept will be at 0, 3. And I can also reflect this point. So it's 2 away from the axis of symmetry on the left, so I can go 2 to the right. And that will be another point just to get some more points on the graph. To find the x-intercept, I want to set my equation equal to 0. And we're going to think of, are there two numbers that multiply to equal 3 and add to equal negative 4? If factoring doesn't work, then we would need to use the quadratic formula. But we're okay because we have negative 3 times a negative 1. Don't need to change the order. Or a negative 3 plus a negative 1. So we'll have 0 equals x minus 3 times x minus 1. And we'll set each of these equal to 0. And solve. So we have a positive 3 as an x-intercept and a positive 1. And then number 4, sketch a graph of the function, which we have already done. Okay, writing quadratic equations in standard form. What information can we gather from the graph of a quadratic equation? Label all the findings on the graph. Looking at this graph, I see that we got 2 x-intercepts. And we have those at, let's see, this graph's counting by 2, so negative 4, 0, and at 2, 0. So make sure you know what your graph is counting by. Then we have a y-intercept up here at 8. I can see the vertex, sorry. The vertex is going to be, so it's halfway between 0 and 2, so we'll say negative 1. And it's halfway between 8 and 10, so we'll say 9. I think that's, I guess we can see our axis of symmetry going through our vertex. I keep adding some things. Our axis of symmetry will be through x equals negative 1. It's always going to be the same as the x coordinate in our vertex, so those numbers should always match. I think that's all we can find. Oh, okay, cool. To write the equation in standard form, which if you don't have standard form written down somewhere, that is our standard form. And in order to write this in the standard form, we need to know what a, b, and c are equal to. Okay, so there are two methods that we're going to go over on how to solve. Option 1, identify the y-intercept. This is the C term of standard form. Okay. So our y-intercept for this graph, which this is the same graph that we just had on the last slide, our y-intercept is at a positive 8. Number 1. Number 2, identify the solutions. These are the x-intercepts. So we said there's x-intercepts at -4 and at positive 2. Write the quadratic equation using linear factors. So just saying I want it in like factored form, which in factored form you want to flip the signs, because when I set it equal to 0 they would flip back. Okay, but we're going to leave this equal to like f of x or y. Don't forget the a term. We're just going to put an a out in front because I don't know precisely how wide or narrow this parabola is, so we don't know what a is equal to. That was 3. 4, expand the quadratic equation. So we're going to FOIL this out. So we'll have x times, I'm going to leave the a outside. X times x is x squared. X times -2 is a -2x. 4 times x is 4x. 4 times -2 is a -8. Let's combine like terms. -2x plus 4x is 2x. This is still equal to f of x. And then we'll distribute the a back in. So we'll have ax squared plus 2ax minus 8a equal to f of x. You could always have the f of x listed first. It doesn't matter. Step number 5, set the c term in the equation equal to the value of c and solve for a. So it's saying we know that c is equal to 8. But in this equation, we have c is equal to a -8a. I can use this to then solve for a. So we'll divide both sides by -8. And we can see a is equal to a -1. And step number 6, we're going to substitute a in the previous step to write the quadratic equation. So they're just saying all of these a's up here, we need to plug -1 in for those. So -1x squared, or just -x squared. 2 times -1 will just be a -2x. -8 times -1 would be a positive 8 equals f of x. And that would be my final answer. Okay, so option 2, we're going to take a little bit of different approach to this. Step 1, we're still going to find the y-intercept, especially if we can see it. You can't always see it on the graph, so just be cautious about that. Our y-intercept is still at positive 8. Identify 2 ordered pairs. If I can see the x-intercepts, why not use them? So if I have an x-intercept at positive 2, these are x-intercepts. Doesn't seem to be working. At -2, no, sorry, that's supposed to be positive. And at -4. If those are 2 x-intercepts, then we're going to have an ordered pair at 2, 0. And at -4, 0. So if I were to write it as x minus 2 times x plus 4, I'm going to change this step a little bit. We still don't know what a is equal to. X plus 4. And this is still equal to some mystery y or f of x. So we'll still FOIL, leaving the a out in front. X times x is x squared. X times 4 is 4x. -2 times x is a -2x. And -2 times 4 is a -8 equal to y. So then we'll distribute the a. A times x squared is ax squared. A times 4x is equal to 4ax. And then a times -2x. Oh, we didn't combine like terms, so we can do that next. That'll be a negative 2ax. And a times negative 8 is a negative 8a, still equal to y. Combine like terms, I should have done that first. So we have ax squared plus 2ax minus 8a equals y. Now originally I had done kind of the instructions that you're seeing here that Algebra Nation recommended, but I think it makes more sense if I keep this method is similar to the other one. This scenario is more for the scenario, or like the opportunity where you don't know what this value is. The other method still technically works for this method. So we want to find a third ordered pair. So you can pick anything. You can do the vertex, you can do any random point, but it has to be on our parabola. I'm going to pick this random point here at negative 2, 8. Okay. This is now going to be my x, and this is going to be my y, so I'm going to plug in negative 2 for x. I'm going to show my work over here. So I have a times negative 2 squared plus 2a times negative 2 minus 8a, and instead of equal to y, I'm saying y is equal to 8. So I have it down so I just have a whole bunch of a's, so I can combine like terms and solve for a this way. Negative 2 squared is 4. 2 times negative 2 is a negative 4a. I guess we can write that correctly. A times 4 is equal to 4a. And we have nothing to simplify here. Negative 8a equals 8. Combine like terms. 4a minus 4a becomes 0. Negative 8a equals 8. Divide both sides by negative 8. And a is equal to a negative 1. So we would now plug a, or negative 1 in for a, into our function to solve. So our final answer, we'd have negative x squared minus 2x plus 8 equals y, or f of x, depending on how you want to phrase it. This will work every time. This other method, or the option 1 that we did, only works if you know what the y-intercept is. But we will practice these more on the next video.